Hi, in this video I'll show you how to calculate the percentage imperviousness per sub-watershed or subbasin automatically if you have dataset for multiple years and if you have multiple study area and if you need to do the same thing over and over. That means for repetitive task you can even make the process automatic. So the same process I already demonstrated in my previous video, the first part of this calculation of imperviousness. So that was the manual process and that was even laborious, and sometimes you may make mistake and then it will be like wasted. You have to do the same thing over and over. So let's see how can we calculate it automatically. So let me describe the data set I have here. So the current data set, for example, I have everything there. So I created a folder named files, and inside that files I already put my data set there for multiple years. Okay, if I make it bigger, if you have like 10, 20, 100, doesn't matter. I have this data set for the conterminous USA for multiple years. And then what I'll do, I'll loop through each of these files and I'll calculate the percentage impervious automatically if I just press one single button. Okay, using basically this is basically Python code, and we can even connect it using model builder here. So I already created that toolbox for you and you can see the process. The toolbox I created here and I already added that, and you can even find the toolbox within my project directory, and here I already added the toolbox. Okay, this is the toolbox. If you can't find it, so you can go to your toolbox and right click and then add toolbox, and you can even direct to that toolbox. Okay, go one step and then you can find it. This is how you can open and add, it will be there. So I added that. So now I can open and I can see. So here I'm just opening it as edit mode, and you can see I have a lot of steps I already added and tested the script extensively. So let me show you the processes I have done if you can remember my previous steps. So what I've done here, that is the for loop, right? So I have a geodatabase, that geodatabase for this project, and here I'm locating the land use and land cover rasters. Okay, so these land use and land cover rasters I have, it's basically locating within my D drive. Let me go to my D drive and connect it, because okay, let me just validate that. If it is like I'm validating, it won't run because it is for other folder. Okay, so if I run it, it won't run because it won't find anything, probably because I did it in this computer. It is running. Okay, see, yeah, let me cancel that. Probably it won't run, that's what I know, because the folder I copied this and it's for different study area. Okay, so it is gonna take a time. It is, see, it is showing you the process, this process here. And then that is the benefit of using this model builder, and you can even connect manually, and then you can see which process is running when it is red, and then if it is done, then you can see and it is moving to the next step. Okay, I have already just renamed everything, and I'm now describing what is actually happening there. Okay, so okay, let me cancel that and let me give you the output. Okay, so here the folder I have, I'm gonna give you the location. This is how you can even start. I'm gonna connect. Okay, connect the folder where I have, it's within my D drive. Okay, the D drive I have here to my PC and the D drive, and then within this folder here I located that. Probably it's gonna be within ArcGIS and calculate imperviousness. Okay, I'm connecting that folder. So now I have that folder. So within this see files. So that is the file I have. I'm adding that file. Okay, add. So now it is showing that directory. So I'm done. Okay. So it added everything there. And then looping through each of these files, this is the function loop, for loop. So it is gonna loop through that folder. And then what it will do, it will give you the raster, and I'll take that raster here. So that is extract by mask. So here we will use that. Okay, we'll use that because that is the watershed, right? We have, means within this study area we have the subbasin. So I'm adding that input raster will be the output of this for loop, and then we'll use that. For example, it's here, and then we'll input that raster or feature as this feature, means the shape file of our study area, and then we'll save that. Where do you want to save that? So we have to locate it. We have to go back, and we can connect it right to our geodatabase, and then okay, within this geodatabase I can even use any raster. So previously it was this, I can even use raster. Okay, so I'm saving it. I have this name. Okay, no, it's not there. Maybe I have to go back to, it's not. So this is the default one I have. Imperviousness, files, geodatabase. Now I can even connect to this raster. Okay, so probably this will be raster 1. Then we have everything. Okay, so this is connected, and now it will create a subset of the entire data set, and then it will give you that masked, right, raster, the raster for our study area, right? We already know that. And then what I have done, I joined, right? I reclassified that field based on our description, 1 for water, 2 for the developed land. So here in this process we are doing this. Okay, it is taking this masked raster as the input raster, and it is taking the value from that, and it's taking that table, land use classification table, and it is adding the type. Okay, so it is giving you another reclassified raster, and we are taking that reclassified raster to make the table and the area based on the subbasin or subwatershed, right? So it is taking that raster, right, that subbasin name from that watershed, and then it is taking that reclassified raster, and we need to connect our output data set. This one, it's okay, let me give you the name, Imperviousness, and then the GIS files, geodatabase. I'm connecting it with our geodatabase. Inside geodatabase you can even connect any tables or the tabulate area, tabulate land use area, whatever it is, tabulate area. Okay, it is gonna give you an area 1 since the name already exists, it's there, and then even it is saving that raster 1. Okay, so it is repeating, so we are done with that. Okay, reclassified, and now it is giving you another table, and we are just joining it. We already done that. Okay, it is giving you this new field, and then we are adding a new field. Which field? Total area, right? Total area and double, it is going to add an empty field. Then what we have done, we added, right, we added the columns, row wise we added all these columns, and here I have done everything, the calculation I did. See, I'm summing water developed every 16 values, so it will fill up that empty field where we have here in the previous step. Then what it will do, then it will even calculate, right, it will add another field, percentage imperviousness or percentage impervious by the same name, so it is going to be another empty field. Then what it will do, it will even calculate the percentage impervious here the similar way. using that field calculator, developed multiplied by 100 divided by total area, because we have already calculated the total area in the previous step. So it is going to do that, and it is going to give you the output table. And then from output table, we're going to save this, right? We're going to save this there. So everything looks okay. Everything is going to give you this percentage imperviousness, and then here, so from this, we're going to save it in our output table, okay? From this ArcGIS, and here we have this land use classification. So I'm going to add a new folder, and then I'm going to give the name as like output LULC, okay? LULC area. So that will be our output folder. We can see, wait a minute, because I'm renaming it. Okay, so I can go inside, and I'm gonna give the name as %name %.xls. So that will be my Excel file. %name means it is gonna give you the output as your input file. So that's why what I have done here, you can see, you can notice that the very beginning of the for loop, I have this name. So this is the name of the input file, and it is reserving this name as name variable. And then at the very last moment, I'm calling that input name, and it is going to add, if your raster name is landuse.tif, so it is going to give you landuse.tif.xls as your Excel file, as the name of your Excel file. Okay, so here let's check what we have inside here. See, output land use and land cover area, there is nothing. Okay, if it runs, I can make it like for a window, I can fit it, and then I can show you the process. I can zoom out because it is a pretty big model. Okay, here you can see what I'm gonna do. I'm just validating the entire model. The connection looks okay if I run it using this button. So currently, see how many input files I have. If I go back and inside this file, I have like 1, 2, 3, 4, 5. Okay, 5. So I'm just testing. Okay, if you have many, it doesn't matter. And I have only one study area which has like 131 subbasin. So it is going to calculate and give you this output based on the 5 different land use information. Okay, so if I hit this button, what it will do, it will loop through each of these files. It will just crop or clip that the raster dataset by your study area. Then it will just reclassify based on the description we have given in a separate table, and then it is gonna make a table, okay, area table based on your subbasin. Then it's gonna add a new field as total area. Then it is gonna calculate the total area, and again it's gonna add another field named %impervious or impervious. Then it is gonna calculate the %impervious from developed land, okay, from developed land area, and then it is the saving as CSV file by the same name of the input file. So let's hit this button and let's see if everything looks okay. Then see, it's read, and then now it's exported, and see, it's pretty fast, right? It's running, and it's doing, maybe everything is okay, and it's calculating and it's doing everything. Let's see if it is gonna give us, I don't know why the process is so fast. It should be a little bit slow. Yeah, see, it's gonna give you, see, pretty quickly it is giving you this. Let's open. Hopefully it is gonna give us the output. See, it's pretty fast, right? And the percentage impervious, you're gonna get total area, and then here. And what I have done here, I added another area from our shape file. So shape files are irregular. That's why I just checked if these two areas are similar. That's why even in another step, I added the area from our shape file so that I can even compare. See, these are similar because the pixel are like a square pixel, 250 meter by 250 meter, but for the same subwatershed or subbasin, the boundary is not that square, so that's why it's a little bit different. So still it's similar, so that's why I checked it to confirm that our calculation is okay or not. Okay, so this is how, see, within like few minutes, but developing this model takes a long time. So it's done. See, it's done. Even okay, now even I can run it again and you can see the entire process. See, it's doing, and it's showing which process is running, and then it's repeatedly doing the same thing. So that's pretty convenient, I feel, that way. And what you can do, even you can export, because that is kind of algorithm you can see the code, what is happening inside or behind the screen, right? Within a few minutes everything is done. But if you want to even modify the script, and if you want to run it within Python environment, you can even do that, because this is the Python script we are running here. But the benefit of using this model builder is to use the toolbox and connect using this connection tool or connection button here. You can even connect. Okay, so I tested it multiple times and I checked it manually. That's why in this second part I just showed you how to calculate that percentage impervious automatically. So that's it. So you can even follow all this process, and you can add it, and you can even test new calculation based on your requirement. And if you feel any difficulty, let me know. I'll try to even show you how to do that as well. So that's it. I'm not gonna even make it longer. So that's it, and thank you for watching this video, and thanks for supporting my channel. Stay safe and take care.